What is the largest prime factor of 1 plus 2 plus 3 plus ... plus 16? So this bit, the ... just means that you just add every number up to 16. So plus 4 plus 5, but it would save space to just put ... Okay, so first of all, we have to actually find what this is equal to, and then we can find out the prime factor. So how do we do that? Well, there's actually a way to do this. If, let's say, you had 5, 1 to 5, add them together. So you could just do this normally and you would get 15, but an easier way to do it would be if you add these two, 1 and 5, you'd get 6, and if you add 2 and 4, you'd also get 6, and then you'd just be left with 3 in the middle, so you can put 6 plus 3. And when you have longer sequences, let's say if they add to 6, you can put 6 times 50, and then plus whatever the number in the middle is. And you can just find the number in the middle by finding the median of 1 to 5, which is obviously 3. So let's do that for this case, because we don't want to add it individually up to 16. Whilst it isn't that bad, it's just going to be quicker this way. So 1 plus 16, 2 plus 15, 3 plus 14, and so on. They all equal 17. So we can put down 17. And now let's find out how many times it appears. So there's 16 numbers here. And because there's an even amount, it means there's going to be so b over 2 is 8, so it's all going to happen 8 times. If there was an odd amount, for example 15 over 2, you know that the 7, it wouldn't work. So what you have is 17 times 7 plus the median, which would be 8 this case. So here this all works out like this. We can do 17 times 8. So that's 136. So now we've got this bit. So we have to find the largest prime factor. So how do you find prime factors? It would be useful if you were familiar with prime factor trees, but basically what it is if you take any number, say 20, and you do this, it's like a tree. This is the top, and these are the branches. And you'd see a prime that goes into this. So a prime, as we know, is a number that is only divisible by itself in 1. So it'd be 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. So here we know that 2 goes into it. So we write 2 here, and then 2 times what gives us 20, and that's 10. But we look, is 10 prime? 10 is not prime. So we do another 2 branches, and what goes into 10 that's prime? Well, 2 and 5, and these are both prime. So we can write 20 as 2 times 2 times 5, and that's their prime factors. So if we do the same thing with 136, see what we get. So we have 136. So 2 goes into this, which gives us 68. 2 goes into 68 again, 34. 2 goes into 34, and 17. Is 17 prime? Yes, it is. So we have 2 times 2 times 2 times 17, and we're told to find the largest one. So the largest is obviously 17. So that would be our answer. So answer for problem of the day for the 17th of June is 17. So thanks for watching, and I'll see you guys next time.